I know this is crazy, right? Making 3 movies in one day. But anyway, I think it's getting close to crunch time, guys. So that's the reason why I want to document this, I guess. I don't know. I don't know. I wasn't planning on making one, but I pulled all this stuff up and it's looking worse than it did this morning. Although the solar wind speed wasn't matching the 1372 kilometers per second. I got you on the geospace. Magnetosphere cut, pressure, and as you can see, I mean, this morning we had some pressure, but it was all just back on the backside. Now the solar winds picked up, so we're getting some front side pressure too, along with all this backside pressure. This is the equatorial plane, so you're looking at the Y cut, flip-flopped on ISWA. In other words, you're looking at the equatorial straight across, sort of and this is like cross section, sort of like a MRI. It's like a slice, cross section slice of the what the magnetosphere looks like from the side. And of course, it bubbles out, all around. It's in sort of a circle, spherical fashion. And this is from the top view. Same deal. I think it's a cut plane. I could be wrong, but I think that's making sense to me, like sort of an MRI segment cut plane snapshot. This is looking straight down on the planet. So here's the integrated space weather ISWA latest. Here's the ISWA latest run I pulled up. It's the Z cut like I was showing you this morning with the solar wind speed. And I glanced at it while I was putting this together. I didn't see it going anything above 7 something. But this is looking a little bit hairier. All this pressure around here, in my opinion. And these radiation belts look like there's more electrons seeping in around the Earth. So you got different gradients of ring colors showing up pretty close to the planet now. And also in here, you got the different energy signatures showing up. And it looks like they're getting pretty close to the planet. So, I mean, you can see with the pressure, what this is doing, it's compacting our atmosphere. So this is what I think. It's compressing our atmosphere too. I mean, it just stands to reason if the ionosphere is getting compressed like it is. Has to be. Then wouldn't it stand to reason that the atmosphere is being compressed? And I think that explains why we're getting these huge amounts of rainfall wherever just a normal rainstorm would have hit, but you get huge amounts of rain. The atmosphere is becoming more tropical across the whole planet. And we're seeing this grid marked magnetic resonant grid mark pattern, which has been here since, I mean, I actually documented it. I think it was in June, early June, on some videos, but I believe it's been showing up probably at least since April, maybe. I don't know, because this has been showing up around the sun on the SDO, magnetic resonant grid pattern. Only shows up on certain angstroms like 335 and 94. Used to show up on the SOHO, but now we're not getting current, look at the date. So we're not getting anything current from Soho. SDO, I think it's like an offset. It's near the Earth. Satellite that shoots the sun. It's sort of near the Earth. That's the one that picks up those celestial bodies that sometimes eclipse the sun. Like back on the 9th, we had the one going up and the one going down. So, I mean, I think one of them was the moon, but one of the other ones had to be something from the Nemesis system, in my humble opinion. So anyway, now what the heck? Okay, 3:35, that's it. Plus, I see a little sun flare kicking off. And I got this on the 1 hour jump, so you can back it up. See that thing, sunspot kicked off about started kicking off like maybe 10 hours ago, 11 hours ago. But that, I don't think that could be what's causing the solar wind speed to be coming elevated. Here's the Discover solar wind speed, the one that's up by Ace at the L1, range 1 position. And as you can see, this is UTC. We're up to 23, 1, 2. Well, it's actually, I think, 23:45, or maybe it's only 22:45. I might have pushed that one up an extra hour. But anyway, you can see the solar wind speed's been climbing, but it hasn't breached 500 yet. And if you watch this here, fairly looking normal, but then you see it's jumping up into the 7-something range. We're getting a lot of this pressure pleating in around the front. I seen an 8 pop through there. So anyway, yeah, I mean, that's what's happening to the planet. This is a cloud feature on Benchy Sky. That's total cloud cover. Now, if you push up the low clouds, see, you still see the magnetic resonant grid pattern. Middle clouds, this morning I looked at this, they were pretty much gone, which is good for us because that's where most of the storms form. Most of our weather forms in the middle layer of the troposphere. And the reason that's being kept at bay is the dry air, which has the acidic acid in it. That's the only thing that's killing these clouds, but even still, and I got this on the water vapor lower level image, which would be, I guess, from the surface up till, well, the troposphere goes up 33,000 feet. I guess that's why planes fly at 35,000. So they stay above the weather, generally speaking, for the most part, at that altitude. But anyway, so this is the dry air represented by the yellows and the oranges. And this all has acetic acid in it, so it's wiping out the clouds. As you can see, in the mid-range, which is where most of the weather comes from. But now that we have this extra pressure on the magnetosphere, on the atmosphere, ionosphere, it seems like the humidity's up everywhere, and we're getting a lot more lower, big looking cumulus type clouds. I'm sure you know what I'm talking about from just your normal observations. Here, look at the humidity levels. This is relative humidity, so that would be at the surface, I would imagine, near the surface. They like to give you dew points nowadays, so I don't know. That's relative to the temperature and when the humidity is going to come out. But even so, well, to me, I'd rather go, for my own understanding, relative humidity. I don't know why they switched to dew points. It has to have some benefit to obfuscate what's really going on. But look at this humidity, 100%, 90%. And the only thing that's keeping it from forming into clouds and just raining everywhere. Because normally you'd see humidity levels like this. I mean, that's going to cause a lot of storms, right, guys? Look at that humidity everywhere. But we're being protected by the dry air, which has the acidic acid and the vinegar. If you put it on the mid-range, that's what you usually see on the Weather Channel or AccuWeather. They like to use this one. And it doesn't show as much dry air in this middle range, mid to upper range. But it's still showing it because, well, they go by temperature. So even at the blue, it's still pretty dry stuff. So you can see that all that blue, that's dry. And even the white, it's still pretty dry. You're not going to get storms in there in that type of air mass. And here's one other thing I wanted to touch on. Been thinking about it for a while. I've touched on it once before, I think. The CAPE index, and this gives you the atmosphere's potential energy. And look at this, it's almost zero, just about everywhere, but we still got these huge systems formed. So that could be nothing but electromagnetic connections with Nemesis, in my opinion. It's driving these winds. Let's look at the wind speeds. Pretty high. And as far as these wind speeds go, okay, like they're saying, look at these wind speeds, 40, 40. Up here we got one going, 45. But they're BSing about Rosa again. I mean, let's see, do all hurricanes. Look, the top wind speed's only like in the high 50s. It's not even a freaking hurricane. But they're calling it a Cat 4, of course. See what I'm saying? Nothing. But I'm not, it's still going to be a problem, no doubt. But I don't know if you're going to get the kind of precip that they're calling for. Here's the 3-hour totals. If you look on the GOES, water vapor loop, we see you got a lot of dry air competing with that Rosa. And if you take it over down to the lower level, you can see it's surrounded by dry air. So that acidic acid's tearing up those clouds. So hopefully we won't get a whole lot of precip when it comes through in here. But I mean, as we've seen with Florence, of course, they're going to chem bomb the crap out of it. So I would imagine we're going to get some pretty bad rain totals up there. And who knows? Hoover Dam's not too far from there. I don't know. I don't know why that popped into my head. But anyway, I'll leave you with that shot. And leave you the links for Benchy Sky. I mean, it's a cool thing to play around with. You can hit air pressure. Just pop it over here to get the numbers you're not used to seeing. waves, humidity. I touched on that's where you get the cave index with the thunderstorms. Okay, I'm out of time. Peace out. God bless.